So and so at this point we had our circles um, arranged in a stack with radiuses um, defined by this graph mapper element, right? And we already shattered our circles in like in a number of segments which we can change. It is our parameter. And what we're gonna do now, we are gonna, so we want to move our segments a bit, like to create this kind of broken broken vase model, which is our goal. Um, so how, like now we should think how we're gonna move our segments. And my suggestion is very simple. So basically, for example, like this is our shattered, this element shatters our circles. This element we use just to show that these circles, they became curves, and now we see breakage points on each curve, right? And now I will just visualize uh, directions in which we are gonna move our um, curves. So basically, for example, this curve, we will use this line which basically connects ends of this curve as a vector, and we will move this curve along this vector to some particular um, length. And we will do the same with this curve, the same with this curve. So they all will be moved along the vector which connects the curve's start and end points. So, and for now, at least for now, we will move all our segments at the same to the same distance, right? Yeah. So that's what we are gonna work on now. So we do not need probably these lines. It was just visualization. So how we can do it? So what we have as output here? As output here, we have, let's make it more visual. So this panel, it allows us to see what's the output of this shutter element. And we see that basically it is a, uh, it's what called in Grasshopper data tree. But basically for us, for now, we will think about it as a list of lists. So this is a list of curves, 3 curves, which were created by shattering a particular circle, right? It is one element of this bigger, like more general list. Next element is 3 curves which were created by shattering next circle, etc. So we have 9 circles, we have 9 elements on our main list, and each element is a list of um, created curves. So now we need somehow to extract vectors and to form vectors. As we are gonna move all our curves to the same distance, probably just one, we need just vectors. We need just vectors from one circle. So basically, let me go back here. So it's, if we go line. So as you can see, all these lines are parallel. So they're all, like, direction will be always the same for all the curves, right? So we need only one, we need to take only one circle, and then we can extract like we need to create to take only curves created by one circle, and then we can extract all the information we need for the vector. Okay, how we can do it? So obviously it's somewhere in sets, because sets, it's basically a collection of items which manipulates with data data as it's represented in Grasshopper, very basic data representation as lists, more complex sets, and the most complex and the most fundamental data representation in Grasshopper, trees. And basically now, as this is, as I said, this is a data tree. So what we need to find an element which will allow us to take just one item from the tree, and this item will be a collection of curves. So probably this 3 item element is what we need. So, and it takes as an input a tree, and we already have the tree. And then what we need data branch path. And path is what we see here. So this is each element in data tree. So data tree represents data elements, and each collection of data elements, and it's each data element, its unique identifier is this kind of set of numbers. It's nothing but a set of numbers. So don't think about it as about anything complex. In Grasshopper, they call it path, but basically it's just several numbers which serve as unique identifier for a particular list. That's it. So let's take the one which is 0, 0, 0. So how we can specify it here? We can say set path, and let's try to enter it this way, 0, 0, 0. I don't think that the brackets are needed. So yeah, it accepted our input. And for now, now indexes. Let's see what our output is for now. For now, our output is just one curve, but and obviously because we are taking just index 0. So this path identified this list, right? It identified this list, and now we need to tell Grasshopper that actually we need all three elements from this list. Just let me see if we can find a better. Let's try tree branch. I think tree branch will take the list, and that's it. We won't need to go to indexes. Okay, we're giving 3, and branch is at what's defined by this particular path. Let's go here, 0, 0, 0, commit changes, and let's see what we have. Now we have all 3 curves which are on this list. So now we have these 3 curves. What we want now, we want to create vectors. And for vectors, a vector is defined by 2 points, right? So we need endpoints of these curves. If we type, double click on the canvas and then type end, and here is an element which called endpoints. So, and we feed it with our 3 curves. And now probably the start and end points, they're just start and end points of each curve. We can proceed and define the vector. Okay, and vector by 2 points. We have several methods to define the vector. And as we have endpoints, probably we need this one, this method. So, and let's point A, point B. And now we have this parameter which called unitize. Let's see how it's set now. It's set to false. So what this parameter actually does? You know, when what vector is? Vector is a direction and in space, and then length given in this direction. In some cases, we are interested only in direction. We are not interested in length. And in most cases, in vector geometry, we are talking then about unit vector. For example, when they say, oh, unit vector in x direction, it means that it's a vector of length 1 in x direction, in axis direction. So why unit vectors of length 1 are so important? Because basically you can multiply this vector with any number, and then you will get a vector of a particular length. So unit vector allows you to easily generate vector of any length going in this direction. So this element, this parameter tells this whole element to produce a vector of length 1. So despite probably this vector from point A to point B, it has a different length, but it will be, say, the length will be changed just to have a vector in the same direction but of length 1, and then it will be easier for us to manipulate with this vector later on. So let's set this parameter to true, and then we can be sure that all our vectors, and there are 3 vectors produced for each of the curves, right? So each of these vectors will be of length 1. And you can see the second vector, it's 0, -1, 0. Obviously, this is a vector of length 1. To others also should be. And if we check length, it's all 1, 1, 1. Yeah. So, okay, so we're going in the right direction. And now we want to move our curves. So, and we want to move them according to a particular multiplication. Probably we need to multiply the vector. So, but first let's look at the move element. Move element, I believe that it should be in transform palette. Let's see. Oh, we can control alt click and it will show us, yes. So move is in the transform palette. So, okay, and it was control alt click. Then you can see where the element in the palette. So, and now, okay, what we need to provide for this move element to work. So first we need to provide the geometry, and obviously our geometry are our curves, right? And then we need to provide the motion, and the motion will be our vector, right? So we have vectors, but we want now we want to be. Oh, let's try to feed these vectors. Okay, and then our we can probably the curves already broken, but we want to be able to vary this the distance. So how we can vary the distance? We need to change vector length. So vector as a geometrical element, it can be multiplied. And actually, you can apply multiplication, like math operation, which is called multiplication, can be applied to a vector. So we will give this element our vectors as parameters, and here we want to use some coefficient. let's use some coefficient here. And let's see in what range. So we want it to be rational. We do not need this precision. Probably 2 points after dot will be enough. And let's vary it from 0 to what? To 10, for example. Okay. So we can set it somehow here. Okay, and then the result of this operation, we are fitting to the motion. Okay, let's see how it works. Yeah, and now we are able to see the moves. Just I want to change. I want to see only preview of the selected element. So, and now we will see how we can break our ways, right? Okay, and if we specify more segments, it will work for more segments too. Okay, so any questions so far? Okay, so then we can go ahead, and what we need now, we need to connect. So as we want to use, first of all, we want to create this, we want to create connecting segments which will like connect our connect the ends of curves, because we want these ways to look like it's still whole ways, right? A little bit shattered, but not completely broken in separate pieces. So we need to connect ends with lines. I want to okay, so but let's do a simpler thing first. What I will ask you to do. Oh, okay. I'm afraid you do not have the same model. Do you have the same model? Yeah, Shangnam,
Yeah.
do you yes?
Yeah.
Okay, good. So what I will ask you to do, first, create lines which connect ends of each curve. Like you see, we have many curves, these segments, right? And create a code which create some add elements which will basically create a line segment to ends of each curve, and then the curve will become a closed polyline. Just do that, and let's see how we can proceed. Next step will be to connect not ends of each curve, but say end of one curve with start point of the other curve. So how it can be done? We need to shift our endpoints. So probably you use this element, endpoints element, to connect endpoints of your curves. So, but you connected start point with end point of a particular curve, right? Now we need to connect start point of one curve with end point of another curve, right? So how we can do it? So we need to somehow change the list of our endpoints. Let's see how it looks. So for example, now we have a list of start point and a list of endpoints, right? So if we look at what our endpoints, like the list of our endpoints, let's look at what we have here. Yeah, so we have for each curve, for each circle, we have basically 6 endpoints. Right, 1, 2, 3, 4, 5, 6. Yeah, right, and we have, yeah, we have 10 of them. Just I'm wondering why we have 6. Oh, or all right. So we moved them. Yeah, because I increased the number. I increased the number of segments. Yeah, so we have 6 endpoints because we have 6 segments now. Okay, good. So the thing, what we want to somehow to connect first start point with, not with, and first start point will have index 0, right? So we want to connect. So for now, we want to connect. It was connected with this endpoint, right? And we want it to be connected with the next one, right? So we want to shift endpoints a bit. And to do that, we need to use this exact element, which called shift. And what we can shift list. So shift list element will take our lists of endpoints. So each section here is a list. So this element will take these lists, and then it can shift them to some particular, according to this, like now it will shift it like once, right? So, and I don't remember in what direction, so it can be shifted towards the end or towards the beginning. Most probably +1, it should be shifted like increasing the index number. So 0 will go to 1, 1 will go to 2, etc. Now, what will happen with the last one? What will happen with the last one depends on this wrap parameter. So wrap is true. So as wrap is true, then the last one will actually go at the 0 position. So it will cycle to become the first element of this list. Let's see how it works. So we do not need this panel which we used for start element right now. Let's use it for the result of our operation. So let's see. It is what we had for endpoints, and this is what we have now. Let's see how it can. Yeah, I want to make it wider. Okay, you see now -22. Just a moment. So it is this element became element 0. This element became element 1. This element became element 2. So I was wrong. So all elements shifted towards the first element. So first element went up one item. Now it's element 0. Then second element became element 1, etc., etc. And the element which was element 0 just went to the and went to the end of the list. So that's what happened. So, and now we can try to use the output of this element to create our connection lines. So we will use line element to connect our lines. And we obviously see from the picture that is not what we wanted, right? So why it happened? It happened because not the right, we shifted our list of endpoints, but obviously it should be shifted differently. Most probably we need to shift it -1, not +1. And you see, now we have these short elements, which basically will interconnect our segments. Let's see, can we do this? Can I select? You see, if I select 2 elements, I see that our lines which we have created perfectly connect end of the segments. So it is exactly what we wanted. Now, what we are going to do now? Now, we want to create a full curve. So now our curves are splitted in segments. So each curve is 12 segments now, with lines and pieces of the circles. So we want to join them to have a full path, and then we can run a pipe for the full path. Like to join them, we will use join element, join curves, I think. Yeah. Let's see, is it? Yeah, I think so. Reaction, yeah. So, and let's, we will use join, but before joining, we need to merge our lines and our curves into one list. Otherwise, this element won't accept them, won't join them together. It will try to join lines separately and curves separately. And it will be impossible because basically they're not curves not interconnected and lines by themselves not interconnected. So they should be provided in one stream. So how we can merge them? We should use the merge element. And then we will give it lines as input and segments as input. Okay, and let's see how it looks. Okay, yeah, it's, let's see how this looks like, the result of this operation. So, and as you can see, now it's a little bit strange because now some of our say these pieces of the curve, they have path 0, 0, 0. These lines, they have different paths. We want them to match. We want them to have in one list because we will be joining them. But now they're separate. Why they're separate? Because output of this one had path 0, 0, 0, 0. Output of and output of this one has like 3 number paths. So we want them to match. Actually, we will look into that more later, but what we want for now, we want this path to match this path. It should be a 3 number path. So how we can do it? Let's see. There is a very simple element, and it's called path mapper. So this element is very useful when you manipulate with tree data. So we will provide this. So what this element actually does, it allows you to remap, to change paths. For example, our current path here has, I cannot, just a moment. So let's look at it again, at our path. Yeah, our paths have 4 numbers and we want them to have 3 numbers. So what we can do, so first we describe our current path, and current paths we will describe it as A, B, C, D. So our current paths have 3 numbers, right? And we want them to have just have 4 numbers, sorry. And we want them, these paths, to be just 3 number paths. And let's get rid of A. A is always 0. We can check it. Let's see. You see for all, oh no, you see the fourth one is always 0 and we obviously don't need it. It doesn't add any information, so it doesn't vary. So we can just get rid of it. So it's the last number. So in data path mapper, we will say that, okay, now we have paths which follow this kind of pattern, and we want the paths to follow this pattern. So we're basically getting rid of this third element. Okay, so and now we will see the output of this element here. Let's see what happened. As you can see, now our paths, they match, and output of this element has also 3 number indexes, and they are all exact indexes as we had from this geometry element. So, and now result of our merge is what we want. Elements of the same with the same index were merged in one list. So that's exactly what we want. These curves and these lines which connect their ends. And we have it for each level of our stack. Okay, now we're ready to provide these elements to the join curves elements. Yeah, and then it will be curves already joined at each level. And last thing we want to do, we want to run a pipe, and we are gonna give it a curve as the input, right? And we want, okay, and it will take some time to generate. So, and then we can add an element to vary the radius. Yeah, and now, yeah, each modification will take time. Because we already, yeah. So, but basically this is, now we have finished our model, and to a little bit reduce regeneration time, I would rather disable pipe element for now. And if you want to play with the form, we have many parameters to play with. We can change the radius. We can change number of segments. We can change how we shift. Yeah. And when we are, yeah, we can change the height, we can change the form of the vase, right? Um, yeah, and we can play with it until we find the form which works for our model. When we find it, then we enable the last element and run, and it will run pipes along our curves. Okay, so any questions?
Actually, I do have a question. I think I made a mistake on path mapper because now the short line connecting all the curves doesn't merge with the curves.
Could you share your screen with us? I
Using
stopped my share. Just share your screen and we will look into it.
the other monitor, but
Oh,
let me see.
oh, you will need to connect to this session from another computer, right?
Yeah.
Okay, just take your time. I think it will be just easier if you share your screen. Let's look at the output of this element. Just use the panel to yeah. No data was collected. You know what? I'm afraid that they're a little bit mistaken in the description of the element, and you need to specify. You need to use not commas, but semicolons rather.
Ah.
Okay, let's see if yeah. Now check. Look at the
Yeah, it
panel.
worked.
Yeah. Unfortunately, yeah, this is the problem with Grasshopper. They're a little bit inconsistent with their notations, and sometimes they even change it on the fly. Uh, so yeah, you cannot completely rely on um, what you see as examples. Okay, so does it work now?
Yeah, it worked.
Yeah. Okay, good.
Thank you.
Good, good, no problem. Yeah, and also this actually talking about the model, um, we can a little bit, let's improve, let's spend some time improving it. I think it worth, it worth, like it will give us some thing to play with and to exercise. And probably it would be better if we go back to the same scheme next time and just to talk about data trees. Hopefully we will have more people. But for now, what I would suggest first to smooth the corners here, and I think it's a very simple thing. You can do that. I'm sure you can do it. But another thing which uh, I would try to explore, if we can change this part of our algorithm to move our our curves not at this all at the same distance, but say to move smaller curves, smaller circles, curves from the smaller circles, to move them a little bit less than curves from the bigger circles. So, and yeah, I would just ask you to modify the algorithm to make sure that they um, that distances are different and proportional to the size of the circle. Okay.
Okay. Move around the length of these short lines. Like some of them could be bigger than the other, I think. Or maybe not.
Okay, just a moment. So your could you change the display to see full names of parameters like it's in display? Yeah, show full names. Yeah. Okay. So you used series branch curve number select. Okay, and then uh-huh, and then you multiply it. But why do you think that it follows the pattern of like that it depends on the radius of the circle? Because you see this series, like this set of numbers which you use to adjust vector length. This set of numbers is completely separate from the circles. So why do you think that it's that the distance will depend uh, on the radius of the circle?
Mm, I'm not sure. I was thinking if like each shift of each circle could be, I mean, like each shift of the curve can be different, then
Mm-hmm.
mm, yeah, I'm not sure how to do it.
It's yes. So you can play with each circle. It's and that's so you can if you are thinking about providing like making independent shifts in each circle, um, it can be done. But what worries me that your element which you used, well, first on it doesn't depend on the radius of the circle, and I think, and it's not exactly what we talked about. But the thing is that it doesn't take number of circles into account, and it means that probably number of produced elements won't be the same as number of circles, like to the geometry move element. And if these numbers do not match, then you will have like, and then um, you will like last element will be used. Like remember how it works. So if there is a least input for if an element has several inputs, and if and each uh, input accepts lists, right? Accept a list, right? Then if some list is shorter, then just last element is used to fill the whole list, like to the length of the longest list, right? So if you follow, if you just to develop your idea, you need to somehow get number of circles as a parameter to your series. It's very important because it will ensure that number of vectors produced matches the number of circles. Yeah, and then it will work better. At least it will be more predictable. For now, it's completely disconnected. And then it means that probably at some, if you check how many elements are inputs for geometry and how many elements are inputs for motion, you probably will see that they do not match, and it probably it creates problems with your model. Okay. Okay, Eric, what Did you create something? No? Hmm. Yeah. Let me show what I would suggest. I'm not sure, actually,
Okay.
I haven't done this before. So it was just an idea which came to me during the presentation. So, but what I would think about like what we did, we used just a particular circle to create our vectors. But if it comes to individual movements for each circle, I would probably generate as many vectors as we have. I would create an individual movement vector for each curve. So if I want to do that, I do not need to extract a particular circle. I want all our circles to be, all our curves basically to be processed. So I will feed this element directly. So I would put this element aside. I don't need it anymore. Right? So, and here I just feed, so I just for each curve, and each curve is different, different in length, right? Um, for each curve, I would create an individual vector. And now, as I want this vector, final vector, to be dependent on the radius of the circle, so, and basically it's not it if it depends on the radius of the circle, it should depend on the length of the curve, right? So I will not, I don't want to unitize this vectors now. So now the length of the vector will be the length between ends of a particular curve. So for longer curve, the vector will be longer. For shorter curve, the vector will be shorter. That's exactly what I need, right? So, uh, and now results should be produced, results should be different. Let's see how it works and if it works at all. So they were, yes, you see, so it works, just it's a question. I don't know, I do not know how much it varies. Obviously, like how, like what's the difference? Like if we, probably if we look from the top, let's see, if we look from the top, can we see the difference for different levels? And now, not, I cannot say that it's such a big. Okay, if we check lengths now, let's see what, in what range our lengths are. So yeah, so they obviously the lengths are the same for each circle, but they are different. So at different levels for different circles, lengths are different. So, but uh, yeah, yeah. So obviously, let's see. Just if we move them too far, then it becomes a bit funny. Let's see how it looks, how it affects our end result. So if we, yeah, can be like that, and yes, so just, you see, like we can play, like when we have geometry, we can just play with the ideas, with like with different ideas and produce very different geometry. If our constant, if we even alter the logic a little bit. So, and I'm sure we can come up with uh, many alterations of the logic, which will produce quite different forms. Yeah, yeah. And I like the one which was produced with same distances more actually. Uh, okay, so this is how we, yeah, this is mm, what becomes like how this figure is transformed if distances are different according to this like very simple logic, like bigger radius, bigger the distance. Actually, I'm sure we can use, for example, we can use graph mapper here to vary the difference more like accurately. Um, if we can do it next time, if you want to go through this exercise, or you can try it on your own when you have a chance. Okay, so what we learned today. Important things. First, uh, we used vector geometry. I'm not sure if you know if you know something from vector geometry, but an important thing that for vectors we can use multiplication, and we can use actually addition, subtraction also operations, and that's how we can create vectors of different lengths, and it's very useful to unitize vectors because then we have vectors of length 1, which basically the basic vector which allows to produce vectors of any length. It was one thing. Another thing, we manipulated with our simple structures, which we already learned before. List was the it now, uh, as we know that there is such thing as data tree as the fundamental data structure for Grasshopper. A list looks like a simple structure. So we learned how to manipulate elements and shift elements to produce patterns. Um, then we were getting ready to learn more about data trees. Next time we will go over the whole model and see how data flows through the model, creating and developing a tree which represents the model data in Grasshopper. But what we know for now, that actually Grasshopper um, keeps lists organized, and it keeps them organized in elements which in Grasshopper called data trees. And basically each element in this data tree, each end element is a list, and this list is uniquely identified by several numbers, which work as a quite complex street address. So you can think like first one is the number for a city, next one number for a district, and then next one the number of the house. So it's a unique identifier for this particular list, and this is basically what data tree is, just lists with unique identifiers. And we worked, it was first time when we worked with our with data trees. We extracted one element from data tree, and it was very simple. You just specify the tree and specify the path you are interested in. So basically the list path is the unique identifier. So and we specified in this case as 000, but basically you can provide any combination of numbers. And if this tree has a list which is identified by this combination of numbers, you will have this list as your output. So it was first time when we worked with trees, and another time when we worked with trees was when we simplified paths. This tree has two complex paths. We will learn why it has two complex paths next time. But basically, we wanted this, it's like they're too complex because they have 4 numbers in identifiers, and last number is always 0, so it doesn't add any useful information. So, and what we did, we just truncated these indexes using path mapper element, and we took only 3 first elements, um, which making indexes on this list similar to indexes on our other list, and then we were able to use merge element just to merge lists identified by the same, which had the same unique identifier. Um, so that's main things we learned today. So next time we will basically use this model which we built today, and we will follow from element to element, analyzing results which were produced and looking how data trees were developed and why and how these elements work together, creating our final uh, representation of our ways.